Hello everyone, welcome to another video. In the previous video, we introduced the idea of what is data, how can we categorize it, what are the different types of ways we can collect data, and I've skipped one of the chapters in the textbook I'm working from because we've already looked at it in the Year 7 content, this idea of bar graphs and dot plots. So we're going to jump straight into line graphs here. Now, some of you may have seen this if you've been following some previous courses on this channel. You may have actually seen some of these before, but maybe hadn't realized it. Now, I'll draw this all together in a minute, but let's just quickly define a line graph first. So, line graphs, these are graphs that consist of a series of points joined by straight line segments. By straight line segments. Cool. Okay, so what does this look like? Well, these graphs, we have a few points, and we are just joining these points together. And we have two axes with different pieces of information being given to us. But now, one important condition for a line graph, something that we actually require when we draw a line graph, is on these two axes. You may remember from previous videos, anytime we saw an X and Y axis, they are measured on these things called, we have these two variables. And line graphs, and these type of graphs in general, they tell us how these variables, so this is, for example, variable 1, and this is variable 2. These things can change together, and they sometimes have an effect on one another. Think back to linear relationships, right? We had these two variables, and as we change one, it affects the other. Now, for line graphs, these are a very special type of graph when showing statistical information. The variables on both axes, so variables on both axes, so the X and Y axis, should be continuous numerical data. So that's interesting. This is some type of condition that we need for line graphs. The variables must be continuous numerical data. So now we're dealing with, if we remember from our previous video, what's continuous data? This is data that's measured, the values are measured on a range. They're measured on a spectrum. So the types of things we're gonna measure, for example, are things along this spectrum, along this range. Remember, these types of data, continuous numerical, these types were, for example, height, or we can also do distance. Some of you may have come up with this in the previous video when I asked you to find your own examples. Weight, time, etc. Now, two of these things that I've written as examples, we have actually looked at before in a previous topic. This was the idea of rates, and in particular, speed, the relationship between distance and time. So these distance time graphs we looked at are an example of line graphs. These are types of line graphs. Remember, we drew these things and we had our distance, we had our time, and we tried to communicate these bits of information about how something was moving. We said that, okay, well, the speed is determined by how the distance changes with time. This is a particular type of line graph. It is, from the definition we came up with, a series of points, 1, 2, 3, 4, joined together by line segments, 1, 2, 3. This is what we mean when we talk about line graphs. They are graphs in data. We can still collect data, but we can make these graphs with which one of these variables, one of these continuous variables, changes with another. So it is a specific type of graph that communicates a specific type of information. Now let's jump straight into some examples. So example 1. And here we want to draw a line graph. So here we have collected, let's consider the data being collected. So the data collected for this question is the temperature in a room at different times. And these times are at hourly intervals. So, if we, for example, drew a table, and this is the data we have collected, all right? So we've sat in a room, we've measured the temperature across different time periods. So that's shocking. That's a really bad table. Sorry guys, bear with me. So we have the time, let's go 9 a.m., 10 a.m., 11 a.m., midday, 12 p.m., and 1 p.m. And the temperature I measured, let's do this in Celsius, was 10, 15, 20, 23, and 18 degrees. Okay, now in part A of my question, I want to present the results, so present the data I've collected as a line graph. Cool, okay. Now, for a line graph, remember, we need two axes. This one here, and this one here. And I'm going to put in my two variables. So, typically when we do these types of graphs, we usually want to put our time on the horizontal axis. We did this with the speed, distance, time graphs, and this will become more apparent later. I won't get into it too much. Let's just, for now, get the time in the horizontal axis and the temperature on the vertical axis. And notice that both of these Variables are continuous numerical. Temperature we measure as a range of values. Time we measure as a range of values. These continuous values on a spectrum. We can get these little in-between values all the way across. Now, I'm going to start at 0 here, and I'm going to go 5, 10, 15, 20, 25, and my time is going to be 9, 10, 11, 12, 1. This is a pretty small graph. Let's actually scale this a little bit. A bit better. So we'll go 9, 10, 11, 12, and 1. Okay, cool. So I want to take my bits of information and represent them. I want to represent my data on this line graph. So my first data point, at 9 a.m., my temperature was 10 degrees Celsius. So at 9 a.m., if I wanted to draw this, my temperature is going to be 10 degrees Celsius. So that is going to be my very first point. And I want to do this for all of the values. At 10 a.m., at 10 a.m., my temperature's 15. So at 10 a.m., my temperature's 15. And I can go along, so on and so forth, with all of my different values. At 11, it's going to be 20. At 12, it's going to be 23. So up here roughly. And at 1 p.m. it is 18. So down here roughly. So I can join up, now that I have my points, I'm just going to join these up with my line segments. So I'm starting at 9, I'm going here, to here, to here, to down here. Once again, I have collected all of my data, these little points, and I'm just drawing them on my axis here. Whoops, that's fine. And I'm drawing them on my line graph. I'm creating a line graph which communicates the difference between the changes with my two variables, with my two continuous numerical variables. Now for part B of this question, I want to use the graph to estimate, so give a rough guess, the temp at 12:30 p.m. Cool. So I've written these hours with this gap of 2 units, this gap of 1, 2, 1, 2, 1, 2, 1, 2. So each second little marker up here represents an hour. So when 30 minutes pass, that is half an hour. So my half an hour ones are going to sit over here. So 12:30 p.m. is going to be down here. And I want to see roughly where is my graph. So if I trace this up, I get my data point here. Let's make this one purple to make it different to the others. Why is that not working? There we go. And I'm going to trace out where this is going to hit on my y-axis. So on my temperature axis. So I get down here, okay, that's roughly 21 degrees. So I've used my line graph to estimate, okay, it's going to be roughly about 21 degrees Celsius at this time. That's how we can use our line graphs once we've drawn them. We can try to make conclusions about all of the different times as well. We can say, for example, okay, at 10:30, let's just try to find the time at 10:30 a.m. I can draw this up to here and along to here. And I can say, okay, that gives me roughly about, let's say, 18 degrees here. So this data point at 10:30 a.m. is going to be about 18. And no matter where I go, I can find different temperatures. Why can I do this? Because the variables are continuous numerical variables. So I can find the time at 9:13. I can find the temperature at time 12:59. I can find the temperature at 10:23. Because these are continuous, I have a spectrum anywhere along this graph, anywhere along here, all the way along my different times, I can find the different temperatures, and I can get really exact about this if I've drawn a good line. But that is how we can draw up these line graphs, and this also shows you how you can interpret this. But hopefully this isn't anything new to you if you've watched the video on distance time graphs as well, because these are already a certain type of line graph that we've already dealt with and tried to interpret. So I won't go any further with this. If you want a little bit more practice and how to interpret these things, you can check out that video in the rates and ratios playlist from year 8. But that is how we can draw a line graph based on two types of data collected. Here we are collecting data for temperature, one continuous variable, continuous numerical, at different times, another continuous numerical variable. But that's it for today. Thank you so much for joining me, and I'll see you in the next video.